this is the back end of the database actually of the DEBUGME social media. It's built on Bubble, and it's built also using the Airdev Canvas framework. This is the database, and of note particularly are two data items in this database. Some data items are populated by the Airdev Canvas framework, but the mint counter data item and the bug data item are two particularly important data items for the function of this application. The mint counter data item is an object or a thing that counts the number of NFTs that have been minted for developers that are using the social media. So the main idea of the social media is for any developer who comes on board, you can post a bug that you're having in your application development, and then other developers can jump in on a remote session with you and help you debug your bug. So when the debugging process is done, if you want, as the poster of the bug, you can decide to mint an NFT for the developer who helps you to debug the bug. So that's basically the whole logic running through the social media. And to keep track of how many NFTs have been minted from the debug NFT connection, which is our NFT collection, we are using the mint counter object. And the most important field in the mint counter object is this counter field that basically counts how many NFTs have been minted. So it just increments every time an NFT is minted, and it starts from 11 by default because the first 10 NFTs in the collection are not to be minted by the public. They are sort of reserved NFTs. So privacy rules are defined on this mint counter data item because it is not meant to be viewed by non-admin members of the application. It's just meant to be seen for security reasons. It's meant to be seen only by the creator of this application or the admin of this application. So the privacy rules defined on this are shown here. Every other person cannot view any of the fields of the mint counter data item. Only the admin can, or only the creator of this object, which is the admin. The other data item, which is important for the functioning of this application, is the bug data item, which has a lot of fields, but the most important field would be the metadata field, the live session URL field. Actually, this is the field that holds the link to your remote session so that other developers can join you in Visual Studio Code or any other IDE you're using. It also has some other fields such as tags, which helps to filter bugs by tags, as well as images. So images is also another very important field because it is from these images, it's actually a list of images that we get the image that gets minted as an NFT. So it's very important that for every bug that is created, at least one image must be attached. So those are the most important fields in this bug data item. So I'll be showing a workflow that runs whenever the mint NFT button is clicked by the creator of a bug. So after a developer might have joined in your session and has solved the bug for you, you want to reward the user with an NFT, you have the right to click on the mint NFT button. That button shows up on the front end, but I won't be showing that in this video because this video just focuses on what happens in the back end. So when that button is clicked, this is the workflow that runs. Now, to mint our NFT, we make use of an API called Tentic API. Tentic API is a backend service is an NFT service provider that takes in a couple parameters that I'll be showing in this workflow, and then it returns a transaction URL. So that transaction URL, when it is loaded, it will bring up a pop-up where you can use MetaMask to sign the transaction that has been set to the Authentic API. So I will illustrate that a bit better. Now, whenever the button is clicked, the workflow starts by showing a loading screen, just a Lottie loader. To the reason why that this is important is because, well, we would need to make some changes to the database. So while that should be going on, the loading screen appears. But generally, the loading screen is implemented for all the pages of the application. So after the loading screen appears for about 5 seconds, the next thing we do is we increment the mint counter object that I showed earlier. We increment the counter field to 1. We increment it by 1 so that another NFT is being minted as an increment from the previous NFT that was minted. We cannot mint the same NFT twice. That would be an error. So that's what this mint counter object is doing. It's keeping track of how many NFTs have been minted, and that's why it's also only important that only the admin can see it, to prevent someone else from just incrementing or tampering with the number of NFTs that are minted. So after the mint counter field has been incremented, we are going to call on an API. So the next 3 steps are actually API calls. So to get this better, I'm going to go to the API connector, and I'm going to show us the 3 APIs that are being called. So the first 2 APIs that are called are under the generate Pinata. Now, Pinata is a service for generating blockchain hashes for files and images. Now, the reason why that is important is because the Authentic API that I mentioned initially takes an hash. It takes an hash of metadata and returns. So it takes the hash of the metadata of the NFT that we want to mint, and then it returns the transaction URL of the transaction, basically. So we want to mint an NFT with an image. Basically, what we'll do is we'll pass the image and the image and the metadata, and pass as well as the address we want to mint it to into the Authentic API, and then it will return the transaction URL. That transaction URL is what we now load in our browser that we can sign with MetaMask. So to generate the hash that is needed by Authentic API, we use Pinata to generate a pin or an hash, basically. So now we need to generate 2 hashes. The first hash we need to generate is our image hash. So of course we have our image currently on our Bubble database, the image of the bug. So we need to first send that image to Pinata so that we get the image hash. After we get the image, that's what is happening in this step 3. We are going to the image that is in our bug's first image. Since we only need to mint one of the images in the bug. So we just choose the first image, or we could also choose a random image, but for the sake of this demo, we're only choosing the first image, and then we are uploading that to Pinata, and then Pinata will return an image hash, or an hash, basically, for that operation. So that hash is what we'll use now in step 4. So in step 4, we have, as you can see here, metadata for all the different attributes of that image or of that bug. Some of them include the value of the IDE. As you can see, it's in VS Code. The language, currently this is static, but basically what we want to show here is we want to show all the different tags that are selected for the bug. So it will show whether it's on the front end, the language that is used, Java, JavaScript, and all of that. All of that will be populated as the metadata for the NFT, and then the description as well as the image. So the image now comes from the image hash that we generated in step 3. It gets populated in step 4 as this image attributes. So now once we have this metadata, this JSON format metadata, that will then be also sent to the Pinata API, and then an hash will also be generated for this metadata. So it is this hash that is generated for this metadata that will now be passed to the Tentic API in step, sorry, my battery is low. That will be passed to the Tentic API in step 5. So once we pass that to the Tentic API in step 5, Tentic will then take the result of step 4 is passed to the Tentic API in step 5. Then the current mint counter, don't forget, mint counter is counting our NFT, the number of NFTs that are minted. So the current value of the mint counter will also be passed so that we know the value, the ID that we are passing to the current NFT that will be minted, as well as the metadata which we are getting from step 4, as well as the address we want to mint it to. So every bug that is created, the user that solves it, it will be stored inside the solver's field of a bug. Let me quickly show that. So inside every bug we have this solver's field here, which is a user. So I know every user actually has a wallet address. So when it comes to the user, we have the wallet address, which is a field. So the solver of that particular bug that we are making an NFT for, that is what we pass as a parameter inside the Tentic API. So once we send this post request to the Tentic API, it will then return a transaction URL which will be loaded on our browser. And then once it's loaded in our browser, we simply, MetaMask will pop up and ask us to sign that transaction. So once I, as the bug creator, I will just see, after I click on the button, all of this workflow will run. Then I will see MetaMask pop up to sign the transaction. And once I sign the transaction, I will simply need to, I'll be deducted the few cents that is needed. Since Polygon is what we are using, Polygon is a cheap blockchain, so just a few cents will be needed. And then the NFT will show up in the wallet of the person who debugged the bug for me. So that's just how the whole workflow works with incentivizing on the DEBUGME social media. Thank you so much for listening.